take up few questions on coordinate geometry's distance formula based. These are kind of a long questions, maybe of 3 marks each. Let me just write down the first question and understand it, then I start solving. Then I show you how to solve it. If P, the coordinates been given as -3, 2, Q coordinates been given by -5, -5, and R, oh god, just excuse me for the spelling mistake, let me rectify, R being 2 and -3, and S also is there, and which has a coordinate of 4 and 4. This be 4 points in a plane. We need to show that PQRS is a rhombus. It's also asking, is it a square as well? Also, find the area of the rhombus. It seems it's not a square, because if they are asking us to find the area of the rhombus, it's not a square. But anyways, let us try solving the question and find out if it is a square or not. How do we go for it? What do we need to prove so that, or what do we need to calculate so that it tells us if it is a rhombus or if it is a square, and how we differentiate between rhombus and the square? Basic requirement, or say the property of square and the rhombus, which is common, is the 4 sides being equal in both the rhombus as well as the square. But the differentiation between the this rhombus and the square based on the property will be, we need to see the diagonals, because in a square the diagonals need to be equal. On the other hand, in a rhombus it is not required for it to be it doesn't require it to be equal. Now we start solving. So let us first find the distance between PQ using the distance formula. Distance formula says it is x2 minus x1 whole square. For me it becomes -5 plus 3 whole square plus y2 minus y1 whole square. That gives me -3 plus -5 plus 3, that is -2 minus 2 square becomes 4. Here is plus -7, so it is 49. So it's root 53. We are not supposed to calculate root 53. We just have to see if all of them we are getting to be root 53 or not. So let it be as it is. Let us now find with QR. Again the same method. 2 minus of -5 gives you a +5. x2 minus x1 whole square plus y2, which is our y2. y2 is -3, again minus of -5, that's giving me a +5 whole square. Then it's 7 square, that's giving me 49 plus 2 square, that gives me 4. Oh, we got it, -53. Now we move on to RS. They will all be equal because they were asking mostly on the rhombus and square. So here for RS it becomes 4 minus 2 whole square plus 4 minus of -3 again, so it is 4 plus 3 whole square. So it's giving me some 2 whole square is 4 plus 7 whole square is 49 again, so that's 53. Just have the last one to go, which is the distance between PS careful with PS. So it is 4 minus of minus 3, that's giving me 4 plus 3 whole square, plus 4 minus 2 whole square. That's again 7 square, which is 49, plus 2 square, that is 4. So that's giving me 53 square root. Now if you see this and they're all equal to each other, so it either is a rhombus or a square. Now just to segregate with the rhombus and square, let us now find out. Suppose now we had assumed this to be P, Q, R and S. To find out the diagonals, we need to now calculate the distance between QS and PR. If the diagonals are equal, that means it's a square. If they are not, that makes it a rhombus. So we'll take up PR using another color just for kind of locating it quickly. PR, so it is 2 minus of minus 3, that's giving me 2 plus 3 whole square, plus minus 3 minus 2 whole square. So it's 5 whole square is 25, minus 5 whole square is another 25, that's root 50. So 25 root of 5 root 2 units. We also need to find out QS. QS being 4 minus of minus 5, that's giving me 4 plus 5 whole square, plus 4. Oh, I need to clear this part which I got dragged. Give me a couple of seconds, just a sec. Done. Now I get back to the solution again. It is QS, so I'm done with the x2 minus x1. So I will be taking up 4 minus of minus 5, that's giving a plus 5 whole square. So it is 20. It's 5 plus 4 is 9, 9 is 81, so it is 81 plus 81, that's giving me 162. Obviously they are not equal. If you see, one is 5 root 2, the other is it is 9 root 2. Yep. The diagonals are not equal, that means it is not a square. That says PQRS is a rhombus. That way we now need to find out the area of the rhombus. Area of the rhombus, if you recall, is given by half the product of the diagonals. So it is half, we know our diagonals being 5 root 2 multiplied by 9 root 2. That's giving us some 90 by 2, that is 45 square units. So we got our answer. Now we move on to take another question based on the distance formula. Let me just write down the question here. I guess we'll discuss the question rather than just directly finding it out, because I guess you now know how to calculate the distance. The only thing is how to go for what calculation would give you the answer. Just let me find the coordinates of the circumcenter of the triangle whose vertices are 3, 0, us understand first what do we calculate, then it becomes really pretty easy. This I think is what they mean when they say this is a triangle first. Let me just name them as well. So this is A, which is given by 3, 0. This being B, it's given by -1, -6. This being C, it's 4, -1. Now what we have to find out is coordinates of the circumcenter. What is a circumcenter? Circumcenter of a triangle is said to be the one which vertex which is equidistant from rest of the vertices. So I just try to assume that it is here, and it should be equidistant from B as well as C and from E. I can give a name to the center as well, so maybe P, and I assume the coordinates of P being X and Y. So you have to find the coordinates of P so that PA equals PB equals PC. You'll get 3 distance formula equation which will give you AP, then you can find BP, and then you can find CP. You will be giving, as because you have a P been given by XY, you will be getting 3 equations. Your first, your second equation, third equation based on the distance formula. That I guess simply done. While you solve these 3 simultaneous equations, you will get the value of XY that gives you the coordinate of the circumcenter of the triangle. Now, once that is calculated, how do you find the circumradius? I can tell you for your help, once you start solving, you will get your X to be 1 and Y, if I recall correctly, will be -3. So that will be your P vertex. If you don't get it right, then I'll surely help you out later sometime. Then to find the circumradius, what is the circumradius? Circumradius is the distance between this PB or PC or PA, which are now equal. So you take either of these 3 equations, substitute X and Y in any of them, that will give you your distance between PA, which is referred to as the circumradius. So that's very simple for you to calculate. So I can also tell you the circumradius will be a √13 units. You can check down with the answers given.